3 ways of time travel, proven by scientists, some of which you can check yourself right after watching this video. The first method of time travel is explained by the theory of relativity, developed by Albert Einstein in the early 20th century. This revolutionary theory asserts that time and space are not fixed quantities. Instead, they depend on the speed of the observer's movement. Einstein showed that time can stretch or compress depending on the speed at which an object is moving. One of the most vivid examples of this effect is the so-called twin paradox. Imagine we have two twins. One stays on Earth while the other goes on a space journey aboard a ship traveling at a speed close to the speed of light. When the space twin returns to Earth, he finds that he is significantly younger than his brother. This happens because time for him passed more slowly than for the twin who stayed on Earth. To understand this effect, let's recall the formula that describes time dilation. This formula shows that as the speed approaches the speed of light, time slows down for the moving object. This time dilation has been confirmed by many experiments, including observations of elementary particles moving at high speeds and atomic clocks that have been sent into space. Thus, if we could reach speeds close to the speed of light, theoretically, we could travel into the future, as time for us would pass more slowly compared to those who remained on Earth. If you want to embark on a time travel journey, subscribe to the channel, like the video, and leave any comment. Then I will create a time machine and invite you to join me on the journey. The second method is gravity, which affects the flow of time. This phenomenon is described by the general theory of relativity, also developed by Albert Einstein. According to this theory, gravity is not just a force, as we tend to think. Instead, it represents a curvature of space-time caused by the presence of mass. To understand this, imagine a stretched rubber band. If you place a heavy object on it, the rubber band will bend. This bending is analogous to how mass curves space-time around it. The greater the mass of the object, the stronger this curvature. According to the general theory of relativity, time flows more slowly near massive objects. This is called gravitational time dilation. Formally, this can be expressed using the equation. This equation shows that the closer you are to a massive object, the greater the influence of gravity on the flow of time. Let's consider a practical example. Clocks on GPS satellites are located at an altitude of about 20,200 kilometers above Earth. Due to the weaker gravitational field at this height, time for these clocks flows faster than for clocks on Earth. If we did not account for this difference, the errors in determining location could amount to up to 10 kilometers per day. The third method is light, which can serve as a kind of time machine and allow us to travel to the past. When we look at stars, we are not just seeing their current light, we are actually observing how they looked in the past. This is because light from distant objects can travel for millions or billions of years before reaching our eyes. If we look at a star that is, say, 100 light years away, we see it as it was 100 years ago. It's like looking into the past. For example, the light from a star that exploded in a supernova 50 years ago has only just now reached Earth. We will observe this event as if it is happening right now. This concept is also supported by observations. Astronomers use telescopes to study distant galaxies and stars, and they often find that many of these objects exist in a state different from what we see. Thus, light becomes our window to the past, allowing the naked eye to witness events that occurred long before humans existed. Since you've watched the video up to this point, I will show you a few bonus methods. One of the most well-known concepts is wormholes, also known as Einstein-Rosen bridges. A wormhole is a hypothetical tunnel that connects two different points in space-time. If such a structure actually exists, it could allow a traveler to move between two distant points in the universe in a short time, bypassing ordinary distances. There are several equations that describe wormholes. One of them, Einstein's equation, looks like this. The problem with wormholes is that their stability requires exotic matter with negative energy, which currently remains just a theoretical concept. Another interesting aspect is closed time-like curves. These are solutions to Einstein's equations that allow travel back in time. They can appear as loops in space-time and theoretically allow one to bypass time. However, the existence of such curves is also associated with paradoxes, such as the grandfather paradox, where a time traveler accidentally prevents their own birth. There are other theoretical approaches as well, such as using rotating black holes, known as Kerr black holes. They might also create conditions for closed time-like curves, but the stability of such solutions and the possibility of their practical use remain in question. Here we are at the end of the video. I hope you feel like embarking on a time travel journey after watching this video. I will try to create a time machine as soon as possible, and you can let me know what the next video you want to see is. I won't say goodbye. See you next time.